Hello viewers, in today's class we are going to solve yet another important problem from definite integrals, right? So here we have this integral that is I is equal to minus 2 to 1 signum of x plus 1 divided by greatest integer x plus 3, right? So here we see that our integrand is a combination of signum function and greatest integer function, right? And here one important thing to note is the signum function appears in the numerator and the greatest integer function it appears in the denominator, right? So while solving this definite integral we have to take care of both these special type of functions, that is signum function and greatest integer function, right? And moreover here we have to be very clear about the definition of signum function and greatest integer function, right? So now here what we will do, we'll try to split this integral, right, as a sum of three integrals, right? So let us see how we can do it. So let us first take the signum function, right? So we know that the definition of signum function is signum of y is equal to plus 1 whenever y is greater than 0, and signum of y is equal to 0 whenever y is equal to 0, and signum of y is equal to minus 1 whenever y is less than 0, right? So this is the definition of signum function, and here we have signum of x plus 1, right? So let us define signum of x plus 1 with the help of this definition. So here we can replace this y with x plus 1, right? So when x plus 1 we take y is equal to x plus 1, then signum of x plus 1 takes the value plus 1 whenever x plus 1 is greater than 0, right? And similarly signum of x plus 1 is equal to 0 whenever x plus 1 is equal to 0, and signum of x plus 1 is equal to minus 1 whenever x plus 1 is less than 0, right? So this is the definition of signum of x plus 1, and here we can solve this inequality, that is x plus 1 is greater than 0, so we have x greater than minus 1, right? And here we have x is equal to minus 1, and here we have x less than minus 1, right? So the point at which we have to break this integral I is x is equal to minus 1, right? So let us plot these points, that is minus 1, minus 2 and 1 on the number line. So here we have minus 2 is the lower limit, and 1 is the upper limit of this integral, right? And x is equal to minus 1, it lies somewhere here, right? Okay, so now if we take this interval that is minus 2 to minus 1, we see that all the values of x are less than minus 1, right? And when we take this interval that is minus 1 to 1, we see that all the values are greater than minus 1, right? So when we take minus 2 to minus 1, then signum of x plus 1 will take this value minus 1, and when we take this interval that is minus 1 to 1, then signum of x plus 1 it would take the value plus 1, right? So now let us first split this integral I as a sum of two integrals, that is I1 and I2, right? So viewers, this is a very interesting integral which we will see in later steps. See, I1 is from minus 2 to minus 1, right? And we have signum of x plus 1 over greatest integer x plus 3 dx, and I2 is from minus 1 to 1, and we have signum of x plus 1 over greatest integer x plus 3 dx, right? So when we integrate from minus 2 to minus 1, all the values of x are less than minus 1, so signum of x plus 1 will take negative 1 value, right? So now we can rewrite it as minus 2 to minus 1, and here we have signum of x plus 1 is equal to minus 1, and we have greatest integer x plus 3 dx, right? And when we take minus 1 to 1, then x is greater than minus 1. So when x is greater than minus 1, signum of x plus 1 will take plus 1 value. So here we have plus 1 for signum of x plus 1, and we have greatest integer x plus 3 dx, right? So now we can rewrite these two integrals as minus 2 to minus 1. We have dx over greatest integer x plus 3, and here we have minus 1 to 1, and we have dx over greatest integer x plus 3, right? So now we have to solve these two integrals. So now viewers, we have arrived at this step by making use of the definition of signum function. Now see, here in the denominator the greatest integer of x appears, right? So now here we have to make use of the definition of greatest integer function. So now if we see this number line, we have here shown the lower limit, the upper limit, and the point x is equal to minus 1, right? So here I can be written as minus integral from minus 2 to minus 1, and we have dx over greatest integer x plus 3. And now see, here we have a very important concept, right? And the concept is, see, here we have to integrate from minus 1 to 1, right? From minus 1 to 1, and the greatest integer x appears in the denominator, right? And we see that between minus 1 and 1, the integer 0 it lies, right? So 0 lies between minus 1 and 1. So we have to further split this integral as a sum of two integrals, right? So the first one, it goes from minus 1 to 0, right? From minus 1 to 0, dx over greatest integer x plus 3, and the second integral is from 0 to 1, right? From 0 to 1, and we have dx over greatest integer x plus 3, right? So viewers, this is a very important step. Now by virtue of the definition of signum function, we are able to split this integral I as a sum of two integrals, that is I1 and I2, right? Now from minus 2 to minus 1, or we can say that between these two integers minus 2 and minus 1, we do not have any integer, so this integral will remain as such, right? But when we integrate this function from minus 1 to 1, we see that 0 appears between minus 1 and 1, or in other words, the integer 0, it lies between minus 1 and 1. So we have to split this integral as a sum of two integrals by virtue of or the appearance of this greatest integer function, right? So we split this integral as minus 1 to 0, and then from 0 to 1, right? So what we conclude from this discussion, that this integral I can be it can be split into three integrals, that is from -2 to -1, then from -1 to 0, and from 0 to 1, right? Okay, so now here let us apply the definition of greatest integer function, right? So when when x it lies between -2 to -1, then the value of greatest integer x is equal to -2, right? And when x lies between -1 and 0, then the value of greatest integer x is equal to -1, and when x lies between 0 and 1, that is 0 and 1, right, then the value of greatest integer x is equal to 0, right? So this is the definition, or we have written the values of greatest integer x in these three intervals, that is from -2 to -1, -1 to 0, and 0 to 1, right? We can also verify these expressions by taking some particular or special values of x between these three intervals, right? So now we can rewrite this integral I as -2 to -1 dx, and for this greatest integer x we can now write -2, and here we can write -2 for greatest integer x, and then we have +3, and similarly we can write the other two integrals, that is -1 to 0 dx, and for this greatest integer x we can write -1, so we have -1 plus 3, and here we have 0 to 1, and we can write dx over for this greatest integer x we can write 0, so we have 0 plus 3, right? So now we see that we have simplified these three integrals, right? So now we can further simplify these three integrals as 3 minus 2 is 1, so we have -2 to -1, and we are left with only dx, right? And here 3 minus 1 is 2, so we have 1 over 2 outside the integral, and we have -1 to 0, and we have dx, right? And here we have 0 plus 3 is 3, so we have 1 over 3 outside the integral, and we have 0 to 1 and dx, right? So now we know that the integral dx is equal to x, so now we can write I is equal to minus, and here the integral of dx is x, and limits are from -2 to -1, and here we have half, and here we have integral of dx as x -1 to 0, and then we have here 1 over 3, and integral of dx is x, and limits are from 0 to 1, right? So now we can simply substitute the limits here, and we'll take the difference, so we have -1 and minus minus plus, so we have here +2, here we have half, and 0 minus -1, minus and minus becomes plus, so we have 1, and here we have 1 over 3 and 1 minus 0, right? So now this is 2 minus 1 is 1, so this is -1, this is half, and this is 1 over 3, and this is -1 plus 3 plus 2 over 6, so this is -1 plus 5 over 6, and this is -6 plus 5 over 6, that is -1 over 6, right? So viewers, the value of this integral is equal to -1 over 6, right? So this is how we solve this integral, and the important and A special thing about this integral is that we have to take care of this signum function and this greatest integer function. Signum function breaks this integral as a sum of two functions, two integrals, and then due to this greatest integer function, we split the integral as a sum of two integrals, right? So the value of this integral is minus 1 over 6.